Good morning, students. Today we are going to discuss about that module number 1, that is basic concepts. Here we are going to discuss about that network reduction method including star delta transformation. So to discuss about this topic like network reduction method, as we already discussed about that number of techniques like mesh analysis, nodal analysis, super mesh, super node analysis, then series and parallel network reduction technique. Then again, why we are using star to delta transformation? Because while we are using that star to delta transformation instead of that series and parallel network reduction technique, some cases, that means in some cases of the networks where it may be in the form of star or where it may be in the form of delta, during that case it is difficult to overcome to find the solution. To find the solution means we need to overcome the difficulty. It is not possible to overcome the difficulty with the known methods like nodal analysis, mesh analysis, supernode, super mesh, or otherwise series and parallel network reduction technique. Though there it is required this star to delta transformation, we are converting that star in the form of delta passion, or we are converting that delta in the form of star passion, and we are going to overcome the difficulty. So that's why today we are going to discuss about that star to delta transformation. First of all, here we are going to discuss about delta to star transformation. To define the formula for delta to star transformation, here first of all we are going to write that what is the resistance which was offered Rx to y. Rx to y, that is Rx plus Ry. We can make it as equation number 1. Ry to z. Ry to z resistance, we can take it as Ry plus Rz as equation number 2. And Rz to Rx, we can take it as Rz plus Rx, we can take it as equation number 3. Now Rxy. Rxy is nothing but the resistance. That time Rxy, that is nothing but the resistance, then it is equal to where R1 is parallel with R2 plus R3, because in this delta connected shape, if I am removing it separately, then R3 plus R2 is in series and again it is parallel with R1. Therefore Rxy is equal R1 is parallel with R2 plus R3. Therefore the formula is represented as equation number 4 at here. Now similarly, however, we wrote the formula Rxy. The similar formula for Ryz is where R2 is parallel with R1 plus R3 and it is equal to R2 of R1 plus R3 divided by R1 plus R2 plus R3. Make it as equation number 5. Similarly, what is the resistance of Rzx, where R3 is parallel with R1 plus R2. Therefore, R3 into R1 plus R2 divided by R1 plus R2 plus R3. Make it as equation number 6. Now by equating the above equations, we'll get, that is, what is the resistance of Rx plus Ry. Rx plus Ry is equation number, Rx plus Ry is equal to R1 of R2 plus R3 divided by R1 plus R2 plus R3. Similarly, Ry plus Rz is equal to R2 of R1 plus R3 divided by R1 plus R2 plus R3. That is equation number 8. Rz plus Rx is equal to R3 of R1 plus R2 divided by R1 plus R2 plus R3. Make it as equation number 9. That is equation 7, equation 8, equation 9 has been right by comparing the left hand side and right hand sides of equation 1, 2, 3 and 4, 5, 6. Then we got here equation number 7, 8, 9. Now subtracting that equation number 8 from equation 7, we get equation number 10. So what is that equation number 7 here? Rx plus Ry minus R minus Ry minus Rz, minus Ry minus Ry, here minus Ry, here minus Ry, can get the remaining Rx minus Rz, that is equal R1 into R2 plus R3 divided by R1 plus R2 plus R3 minus of R2 into R1 plus R2 into R3 divided by R1 plus R2 plus R3. We can write it as equation number 10 at here. Now here, then adding this equation to equation number 9. So now adding that equation number 9 with equation number 10, then here Rx minus Rz in the left hand side, Rx minus Rz plus Rz plus Rx. Here minus Rz plus Rz cancel. Here Rx plus Rx can become as 2Rx at the left hand side, and the remaining equation can become as like this. Here denominator is same, we can add that all the numerators and we can write it as like this. And here in this equation, here plus R3 R1 and here plus R3 R1, we can write it as 2 R1 R3. Remaining here R1 R2 plus R1 R2, here minus R1 R2 get cancelled. Here minus R2 R3 plus R3 R2 get cancelled. Then remaining R3 R1 R3 R1, it becomes 2 R1 R3. The denominator is same. Next, now we got that 2Rx is equal to R1 into R3. So in the numerator 2 will get cancelled, and Rx is equal to R1 R3 divided by R1 plus R2 plus R3. Similarly, if you wrote the same method, we got Ry is equal to this formula and Rz is equal to this formula. That is Ry is equal to R1 into R2 divided by R1 plus R2 plus R3, and Rz is equal to R2 into R3 divided by R1 plus R2 plus R3. However, here we wrote the formula, that means we are converted that delta resistors R1, R2, R3 into star resistors values like Rx, Ry, Rz. Now it's another turn to convert that star network into delta network, because just now we have completed delta into star. Now star to delta transformation. To convert the star to delta transformation here, now I am going to take that star to delta. In case of star to delta, here I want the what is the value of R1. Here the value of R1, how it is constructed means it is constructed between the terminal x to y. Between terminal x to y, if it is a resistor which is constructed as R1, then R1 is equal Rx into Ry plus Ry into Rz plus Rz into Rx divided by opposite resistor, that is Rz. Then we may get R1. Similarly, what about that R2? The value of R2 is constructed between y and z. That means y to z. What is that? The value of ryz here. The value of ryz, again the product of ry into rz plus again rz into rx plus again rx into ry divided by the opposite of z and y resistor is rx. So divided by rx means here we will get that the value of ryz. In similar way, again we can also find out that one more resistor value, that is Rzx. Rzx means we have to construct a resistor which is connected between Z to X. So Z to X is nothing but here R3 according to delta. The value of R3 is equal to again here Rz into Rx plus again Rx into Ry plus again Ry into Rz divided by opposite branch of Z and X is Ry. So divided by Ry. If you do the simplification, again here we got that the equation, that is R3. So this is the way how simply we can convert that star network into delta network. So and it's vice versa. So by this here we are going to simplify the difficulty in the network or in the problems where the network is connected. One network is in star and one network is in delta. For suppose if it is the network which is connected in star, one network is connected in delta. If I want to simplify means star again is connected in star means it is easy. How the star is again connected in star means there if star is connected again in star, then two stars are connected together. then this resistance, this resistance, this resistance, this resistance, this resistance and this resistance are in parallel, and easy to find out that ultimate answer. So this is not one of the simple technique like nodal mesh, supernode and super mesh, and series and parallel network reduction technique. And this can overcome the difficulty where there is a one star and one delta. It is difficulty to reduce the network. That case we are converting either delta into star or star into delta according to our comfortable value. There we can find out the ultimate solution. So this is that uses of star to delta and delta to star transformation. Thank you.